Okay, so here we've got a situation where we've got two forest rangers, and they're up in their fire towers, and they are observing the same fire. Renee's tower is 19 kilometers due east of Michelin's. So 19 kilometers due east, well, we figure out where east and west are. So due east would be this way, in this direction. So Renee's tower would be over here, Michelin's would be over here to the left. And we see Renee sights the fire on a bearing of 305 degrees. Well, if we just do a quick compass rose here, 305 degrees, we go around 90, 180, 270, so it's going to be up. So it's going to be on an angle like that. So because it's going up towards the writing of the question, we want to sort of start this a little bit lower so we've got room to draw the diagram. And Micheline sights the fire on a bearing of 32 degrees from her tower. So she's over here, and she has a sight line of 32 degrees, so it's not all the way down to perfectly east, because that would be 90 degrees, 32 degrees would be a little bit above that. And like I said, it doesn't have to be perfect angles, but at least you get the general idea. And so we see that it's going to be, the triangle is going to be drawn up like that. So I can go ahead and kind of formalize this a little bit. So I'm going to be drawing this like this. I'll draw the ends of the compass rose there. I'm going to draw the north and south part of the compass rose as well. There's north, and here is the compass rose there. So this is Renee's tower over here. This is Michelin's tower over here. There's 19 kilometers in between, due east. And so Renee sets the fire on a bearing 305 degrees. So 305, remember we got 90, 180, 270. So from 270, 305 is 35 degrees above that. So we're going to ballpark it like this. And for Michelin's tower, she sees the bearing of the fire at 32 degrees. So 32 degrees from north. It doesn't go all the way down to 90. It goes a little bit down here to 32. And so I'll just draw this up like that. So right in here is 32 degrees. And if we know all the way around here is 305 degrees, the bearing is 305 degrees, what's this little distance back in here? So that would be 55 degrees. And actually, since that's outside the triangle, that's not that helpful for us. What we do want is we want the angle inside here. So if we know this whole quadrant is 90 degrees, this is 55, so 55 from 90 would give us 35 degrees in here, which you could also get from 270, 305 degrees and 270. We just subtract that to get 35 inside the triangle. And over here we know this is 32, we know the whole quadrant is 90, so that means that this is going to be 58 degrees. Okay, so we need now, we need to solve this triangle basically. We need to know how far this distance is from Michelin's tower to the fire, and from Renee's tower to the fire. And this time, because I labeled those values, then I can draw the correct, or label these side lengths correctly. And I'll just put F for fire. So what can we do now? We need to know this side and this side. Do we have a right angle triangle here? I don't think 35 and 58 add up to 90. So we don't have a 90 degree triangle, so we can't use sine, cosine, or tangent. Do we have any complete ratios of angles over sides, angles over sides, angles over sides here for sine law? Or do we have an angle, or a contained angle, and two known sides? Do we have two known sides and the contained angle? Well, what would be the next best thing we can do here? Well, that was the scenario to use the cosine law. Can we use some of our information about triangles to find one of the missing pieces of information there? What would we find next? Okay, so we've only got one side length, but we do have two angles, so we can find this angle by subtracting the sum of those two angles from 180. So that would be 87 degrees. So close to 90, but not exactly. So we know that's 87 degrees, and then now that we have that angle here, we see that we have a complete ratio. So now we can use the sine law because we've got that complete ratio. So to find the side length, we want to have the side lengths on top so we don't have to do one extra step of the calculation. So if we're going to find side r, what would the sine ratio or sine law look like then? Okay, so we've got r over sine r, which is 35 degrees, and that equals 19 over the sine of f, which is 87. Okay, and then because we're dividing here by sine of 35, what would we do on both sides to get rid of that sine 35 to isolate the r? Okay, we're going to multiply both sides by sine of 35. So we end up getting r equals 19 sine 35 over sine of 87. Okay, and then I'll let you do that calculation. Then for side m, we just do the same thing. So we've got m over the sine of 58 equals, again, 19 over the sine of 87. Here, notice that we're dividing m by sine of 58. So in order to get the m by itself, to isolate it, we have to multiply both sides by sine 58 to cancel that out. So we're left with m equals 19 sine 58 all over sine of 87. And then I'll just let you calculate that and consult with your friends to see what the correct answer is. Okay, now that you finished that, move on to example 3. So here we've got radar screen, airport control tower. Shows that there are two planes at the same altitude, and according to the rangefinder, one plane is 100 kilometers away in a direction of north 60 degrees east. The other plane is 160 away, direction of south 50 degrees east. And we want to know how far apart the planes are. So again, we're going north. So for this plane, from wherever we start, we're going north 60 degrees east, and east is that way, so we're going to go 60 degrees to the east. So we don't want to have the point that represents the radio control tower to be really close to the edge of the paper, because we're going to be going off to the right. So let's maybe move it around here-ish. So we're going north 60 degrees east, and I'll just draw the compass rose here. There's north, 60 degrees east. So north 60 degrees east, well, of course, going east, that's 90. It's not, of course, all the way down to 90, but it's 2/3 of the way down there, so 60 degrees would be kind of like, oops, on this angle. And so this is 60 degrees east there, which means that inside here is going to be 30 degrees. And we know this plane is 100 kilometers away. Then the other plane is 160 kilometers away in the direction of south, 50 degrees east, so south, 50 degrees towards the east. So it's a little bit more than halfway along. and it's 160 degrees, so this is 50 degrees here, which means that this is going to be 40, which means that the angle between is going to be 70. This is 160. We want to know how far the two planes are apart, say D. So, when we see that diagram, we see we've got a side and the angle between them. So is that a trigonometric ratio of sine, cosine, or tangent? Or is that the sine law? Or is that the cosine law? Great, yes, that is the cosine law. And again, so we're just going to set this up. We need to find this distance here. So that's going to be d squared equals 100 squared plus 160 squared minus 2 times 100 times 160 times the cosine of 70, the angle between them. Okay, so please go ahead and do the calculation and find the distance between them, distance between the two planes, and then consult with your friends to see that you've got the correct answer. Okay, so there's the work for the bottom at the bottom of the page there. This is the last bit of the last lesson homework for this semester, so congratulations, you've made it through, and thanks for watching, and we'll see you in class.